Hello, my name is Christopher Peña. The topic of this video is expressions and equations with radicals. In this video, we will review the concept of radical expressions and its notation. Let's begin the review by asking ourselves the following question. What is a radical expression? Well, a radical expression is an expression that uses a radical symbol to indicate the root of a number. Note, the root of a number is a value whose repeated multiplication equals a given number. And so, if we consider a positive integer n and a real number b, the following expression represents the nth root of b, where n is called the index and b is called the radicand. In general, this expression is used to represent a value that when multiplied n times gives us the number b. Note, in this expression, if n is even, then b needs to be greater than or equal to 0. Let's now look at some examples. The first example represents the cube root of 8, and we want to evaluate this expression. This means that we need to find a value that when multiplied 3 times equals 8. So let's look at the value of 8. If we factor 8, it equals to the product of 2 multiplied by 2 and multiplied by 2. In other words, 2 is the value when multiplied 3 times gives us 8. And so, the cube root of 8 equals 2. Let's look at another example. In the second example, we have the square root of x to the power of 4. To evaluate, we need to find a quantity when multiplied 2 times that gives us x to the power of 4. So let's look at x to the power of 4. This equals x raised to the power of 2 plus 2, which can be factored as x squared times x squared. Note, this expression is obtained using the product rule for exponents. If you're unfamiliar with this rule, please review the video titled The Product Rule for Exponents. And so, x squared, when multiplied 2 times, gives us x to the 4th power, which means the square root of x to the 4th power equals x squared. Now, let's practice the concept of the nth root of b by simplifying the following radical expressions. If we look at the first example, we are given a radical expression that does not have an indicated root. But note, when the root is not indicated, this implies the second root. And so, in this first example, the root is 2, which means we have the square root of 36. To evaluate, let's look at the value of 36. If we factor 36, it equals to the product 6 times 6. So 6 multiplied 2 times equals 36. This means the square root of 36 equals 6. And this is the result of the first example. Now, let's look at the second example. To begin, let's focus on the radical expression, which is the cube root of 64. Using the 64, if we factor 64, it is equal to 4 multiplied 3 times. This means the cube root of 64 equals 4. Now, going back to our given example, which is 5 times the cube root of 64, we now know this equals 5 times 4, which equals the value of 20. And this is the result of our second example. Now let's look at the last example. This radical expression represents the 4th root of x raised to the power of 12. As before, let's start with the inside of the radical expression, which is x to the power of 12. notice that this equals x raised to the power of 3 plus 3 plus 3 plus 3, which then equals x cubed multiplied 4 times. This expression is obtained using the product rule for exponents. Again, if you're unfamiliar with this rule, please review the video titled The Product Rule for Exponents. And so, since x cubed multiplied 4 times equals x to the power of 12, this means the fourth root of x to the power of 12 equals x cubed. And this is the result of our last example. Now, go ahead and try working some examples on your own. At this point, please pause the video and simplify the following radical expressions. Afterwards, continue the video to see the solutions. So let's look at the solution to the first example. The first example represents the fourth root of 16. To evaluate, let's look at the value of 16. And notice that if we factor 16, it's equal to the repeated multiplication of 2 4 times. And so, the fourth root of 16 equals 2. And this is the result of the first example. Let's now look at the second example. This expression has the cube root of 27. To evaluate, let's look at the value of 27. By factoring 27, we see that it's equal to the repeated multiplication of 3 times. This means that the cube root of 27 equals 3. And so, negative 2 times the cube root of 27 equals to negative 2 times 3, which equals negative 6. And this is the result of the second example. Now let's look at the third example. For this example, recall that a radical symbol without an index implies that it's the second root. This means that our given radical expression has an implied second root. So this expression represents the square root of c to the power of 6. To evaluate, let's look at c to the power of 6, which equals c raised to the power of 3 plus 3. In turn, this equals to c cubed times c cubed. Again, this expression is obtained by using the product rule for exponents. If you wish to review this rule, please review the video titled The Product Rule for Exponents. So now we know that c cubed times c cubed equals to c to the power of 6. And so, the square root of c to the power of 6 equals to c cubed, which means 4 times this expression equals 4 times c cubed. And this is the result of the third example. With this last result, we conclude our discussion on radical expressions and its notation.